Welcome to my pre-algebra class. We're on Chapter 12, Section 3. And we're going to be working with the counting principle. And this is a shorter way of finding the total number of possible outcomes without doing a tree diagram. So to find the number of outcomes for an event, we multiply the number of choices for each different category of an event. So for example, find the total number of different music systems that can be chosen from the following: 4 types of receivers, 3 types of speakers, and 2 types of CD. So that's 12 times 2. There are 24 possible ways of selecting those. Then when we apply this to probability, the event is choosing a number from 1 to 20 at random, then picking a letter A through W. So what's the probability of getting an odd? Well, from 1 to 20, there are 10 odds out of 20 possible numbers, times a C or a D. Probability to get a C or D is 2 out of 26. And then we can cancel. So our probability is 1/26. And that's much faster than doing a tree diagram. So with that in mind, we're ready to do the evens. You get a piece of paper headed for page 550, exercises 1 to 23, and titled down. And we're starting with number 2. It says use the counting principle, find the number of possible outcomes. Choosing a letter A through X, so that would be 24, and a digit 0 through 9. And there are 10 digits. So multiply that together, and we have 240 possible outcomes, which I don't think anyone wants to do a tree diagram on that. Number 4, choosing an outfit from 3 sports coats, 4 shirts, 5 ties, and 3 pairs of pants. So if we times those together, see, 5 times 4 is 20, and 3 times 3 is 9. 20 times 9 would be 180 possible outcomes. Problem number 6, use the counting principle to find each probability. A coin is tossed 4 times. Find the probability of all heads. So that's a probability of heads, 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 and heads. Probability of getting heads the first time, there's 1 head out of 2. Probability of getting heads the second time, 1 out of 2. Probability of getting heads the third, 1 out of 2. And the fourth, 1 out of 2. So that's 1 out of 16. 2 times 2 times 2 times 2 is 16. Number 8, a coin is tossed 6 times. Probability all tells. So probability tells, 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 tells. Well, there are 2 ways a coin can be tossed. So 1 out of 2 for the first one times 1 out of 2 for the second, and so on for all 6 of them. There's only 1 tail out of the 2 of them. So that's going to be 1 over 2 to the 6th power, which is 64. 2 times itself 6 times. Number 10. In exercises 10 through 17, refer to the number cube, spinners, and cards at the right. They determine the number of possible outcomes. Spin spinner A. Spinner A has 4 outcomes, and spinner B. Spinner B has 3 outcomes, so 4 times 3 equals 12 possible outcomes. Number 12, spinner A, spinner B, and a card. Spinner A has 4 outcomes, spinner B has 3, and there are 5 cards. So 4 times 3 is 12, times 5 is 60 outcomes. Problem 14, find each probability. You draw a card and spin spinner B. So what's the probability when you draw the card that you get a V and not blue? Okay, look at the cards. How many cards are V? Only 1 out of how many altogether? 5. Times, how many are not blue? Not blue in spinner B, there's 2 that are not blue out of 3. So our answer is 2/15. There was no canceling on that one. Problem 16. You roll a number cube, spin spinner A, and select a card. So what's the probability of getting a 2 on the cube, a red on the spinner, and an X on the card? Well, how many ways can you get a 2 on the cube? 1 out of 6. Times red on the spinner A, there's 1 out of 4. And an X, there's 1 out of 5. So 5 times 4 is 20, times 6, it's 1 over 120 is your probability. Number 18 and 19, license plates for motor vehicles usually contain 6 symbols. The first 3 symbols are often letters from A through Z, and the last 3 symbols are often digits from 0 through 9. Number 18, how many letters are there from A to Z? 26 possible ways. Number 20, use the counting principle, find the number of different license plates possible. So it's a letter, a letter, a letter, a number, a number, a number. So it's 26 times 26 times 26 times 10 times 10 times 10. And using the calculator, that comes out whoops, let me clear that. That's 26 cubed, because we use the time, plus 10 cubed. And I can't multiply. I should supposed to multiply. Let me fix that again. 26 cubed times 10 cubed, because there's 3 of those. And that gives us 17,576,000 ways. So that's a lot of license plates. And 22. In exercises 22 and 23, assume that no letters and no digits can repeat. Use the counting principle, find the number of different license plates possible. So for the first letter, I can use all 26 of them. For the second one, I can't repeat, so I only have 25. For the third one, I can't repeat, so I only have 24. For the numbers, I have 10 to start with, and I can't repeat, so the second number I only have 9 to choose from, and then the last number I only have 8 to choose from. So I'm multiplying that out, I have fewer. 26 times 25 times 24 times 10 times 9 times 8 gives me 11,232,000. And that concludes our evens. Be sure you check the back of the book for the odd answers.